So that's saying if you have two exponential equations with the same base that are equal to one another, then that means the exponents have to be equal. Now the key, the base has to be the same. It has to be written once on each side, so I don't have multiple pieces over here, just one thing. So these are different to solve versus the problems with like a square root and a cube root, because we could add radicals. But if our variable is in the exponent, then we don't have that option. So let's take a look at some. All right, so right now, I can't just set any exponents equal to each other. My goal is to try to get the same base. So 3, can I break 3 down at all? No, that's as low as that one is going to go. 81, can I rewrite that? What should it be? It's 9 times 9. So that would be 9 squared. But that's getting me closer. Ideally, though, I want these bases to be the same. So there are different ways of writing it, but the easiest way, the most direct way to solve them, is to rewrite it with the same base. Now you notice I haven't changed anything. What is 3 to the 4th power? 81. I didn't add anything to my equation. I just rewrote that number. Now the bases are the same, so what has to be true?
X plus 1 equals 4.
X has to be equal. So x is 3. And you can check yourself if you plug it back in. 3 plus 1 is 4. 3 to the 4th is 81. Okay.
No, yeah.
I don't think I've done anything to make you cry yet. All right. This one, 2 to the negative x. So I can't break down 2. How could I write 16? So that means negative x has to equal 4. And x is negative 4. Do you guys remember doing these before?
Yes.
Good.
Do we have to check them to see if they actually work?
So on these, I recommend checking to catch mistakes, but since we're not adding radicals or squares or anything, if your math is right, you won't get extra answers. So all of your answers should work unless you made a mistake in your problem.
It's so good. With ice and from yesterday. It's like,
Oh,
like that.
Yes.
It's the best taste ever.
I had a full cup of water left. I can dump it out because it's the ice melted.
Wasteful.
I'll water a plant. Okay, so what would I do here? Same base. What base could we use?
1/5.
Okay, we can stick with the 1/5 if you're not scared of fractions. 1/5 to the x. So the question is, 1/5 to what power is equal to 1 over 25? So x is 2. All right, you guys do D. So 2 to the 2x minus 1 equals 4 is 2 squared. And here's the 3x. All right, let's look at E. Can I write them both with a base of 8? What are we going to have to do then?
Break the 8 down.
We're going to have to break the 8 down. What base can we write 8 as?
2
2 to the third power. And that negative x plus 14 just comes down. 16 is 2 to the...
or 4. I don't see.
Alright, now we can't drop these bases yet. Exponent rules. If you have a power to a power, what do we have to do?
Times them.
So that gives me a negative 3x minus 42.
What? Oh, wait.
Oh, sorry. I just repeated negative 3 plus 42.
What?
Equals 2 to the 4x. Now we have the same base, so now we can set them equal to one another. So if we add the 3x, divide by 7, and we get x equals 6. What base do we use?
3.
Okay. So we have 3 to the x squared minus 7. 27 is
3.
to the 2x. So, what do we do with these exponents? Multiply them. So that gives us 3 to the 6x. So now, we can set these equal to one another. Subtract over the 6x. Factors into x minus 7, x plus 1. So we get positive 7 and negative 1. Both of those options, we haven't done anything that should make them not work, but we could certainly double check and make sure. You have a calculator, so it's not that big of a deal. If you type in 7, so if you have 3 to the 7 squared minus 7 power, you get this huge number. If you type in 27 to the 2 times 7 power, you get the same huge number. Okay, you can do the negative 1. So, anytime in doubt, go ahead and plug them back in and check. It is possible to get multiple answers on these, like we did here. I want you guys to try this problem. So we have 3 to the x cubed. 9 is 3 squared to the x. So 3 to the x cubed equals 3 to the 2x. So x cubed equals 2x. Several of you stopped here. Just set it equal to 0. And what can we factor out?
X.
So if you set that equal to 0, we get x equals 0. For here, x squared minus 2 equals 0, so x squared equals 2. Square root, with that you have to do plus and minus, so that's plus and minus is what we do. And of course you can check them. Alright, let's try this problem. Can I multiply my 4 and 2? Order of operations says you have to do exponents before you multiply. So I can't multiply these yet. What else could we do? Change the base. We really have 3 bases here, 4, 2, and 16. We need all of those to match, so we're going to change all of them to 2's. So 4 is 2 squared. 2x squared. 16 is 2 to the 4th. So this becomes 2 to the 2x times 2 to the x squared equals 2 to the 8th. When these are multiplied, what do you do with your exponents? So that's x squared plus 2x. And now I can set my exponents equal to one another. X squared plus 2x minus 8 equals 0. Factors into x plus 4, x minus 2. So negative 4 and positive 2. So do not drop your base until it's only written once on each side. Try this one. So what's my common base? So how would we write 1 over e squared?
E to the negative 2.
E to the x squared equals, if these are multiplied, we add exponents, so that's 3x minus 2. So x squared equals 3x minus 2. So we set it equal to 0. Multiply to positive 2, add to negative 3.
Negative to negative 1.
We're going to do one more together and then I'm going to give you guys a couple to try. What do we do? Okay, how would you rewrite that? Or what could you do about the radical? Cube root is a 1/3 power. Alright, 1/5. How would we write that one? Negative 1. So power to power we multiply, so we get negative 1/3 x. This would be a negative x minus 2. We set the exponents equal. Add over our x, so negative 1/3 plus 1 would be at 2/3 x equals negative 2. Divide by 2/3 or multiply by 3/2. And we get negative 3. Alright, I'm going to put 2 problems up here that I want you guys to try. take a look. So the first one seemed to do okay with, got a common base. So this is a 2. We changed the 4 to a 2 squared, and that's to the 3x. 1 over 64 would be 2 to the negative 6. Actually, it was on the bottom, so it had a negative. So our goal, we had 3 bases here. We were trying to get them all to be the same. Did anybody start out dividing by the 2? Okay. So we can work from here. Power to a power we multiply, so that would give us 2 to the 6x. If these are multiplied, what do we do with the exponents? So this is a 1, so it's 1 plus 6x. And then, since we have the same base on each side, now we can set the exponents equal. So 6x equals negative 7, and we get a negative 7 over 6. Second one, we seem to be struggling with that one a little more. What do you do about the 1.5? 3 halves. Can we write 27 over 8 as 3 halves? And that whole thing is still to the x. So we get 3 halves to the x plus 1 equals 3 halves to the 3x. So x plus 1 equals 3x. Our x is 1 half. Any questions on those two? Then I have one final problem for today. Here's our last. What are your thoughts?
You can't do it.
We
Can you
can.
take 1 time 1 2, but not 1 2 5 like after in parentheses?
So you're saying multiply by 5? Is that what you're saying?
If I don't
What?
I don't actually know that.
Times
I was
5?
saying I do 2 parentheses, but it still won't matter.
There's really 2 different approaches. So this one isn't a bad approach. We know on an equation, if you do the same thing on both sides, it's legal, right? This is a 5 to the first, so when you multiply those, what would you do with your exponents? So that's 2x minus 2 now. And 1 times 5 is 5. So this is the first power. So we would have 2x minus 2 equals 1.
You wouldn't have to take the 5 and 5.
No, because we added their exponents. So when you're multiplying, the base doesn't change. So we get 2x equals 3 and x is 3 halves. So that's one way of doing it. The other option is to get a common base. We need this to be 5 to some power. So the question is, 5 to what power equals 1?
0.
0. And then you could say 2x minus 3 equals 0. And we get 3 halves again. So 2 different approaches, but both of them work. One can be written as any base. You just make whatever your base is to the 0 power, and it would always equal 1. All right, so that's my stopping point. There is a handout posted on Google Classroom. It's fairly long. I want you to do, let's just do to the odds.